Thank you to everybody who survived until the last talk of this very dense conference. So the last speaker of this conference is Tatsuki Kuwagaki from Kyoto University, and he will speak about Hodge microsheaves on cotangent bundle and planning. For you, I'm very happy to share with you. So today I will talk about Hodge microsheaves. So let me first give a picture as an introduction. So there are in the world there are so many fire type categories of synthetic firefoods. So a general feature of such a category is it consists of Lagrangians with some additional data. For example, this is Lagrangian local system and some more additional data. So as a special class of categories, the one introduced in the previous talk, we have so-called partially wrapped categories. Categories of Weinstein vectors. And as Doran already mentioned, we have a kind of theoretic description of these categories called microsheaf categories. the most general kind of this statement is so these local systems are unitary local systems. Is it correct? You can arrow actually more. So GGM and GGM. More general? Yes. You can. Yeah. For definition, they used only words. But there is a version, actually. And may I ask you why in the previous talk there was no this local systems? I think it's for simplicity. Right? Sometimes you can recover them as modules. Very or you just wait. Last question, right? So don't wrote it as brain. So it's one of brain data. Brain. This part of the brain instruction.
Actually, you can define that local system in this RAM setting. The ones with local system appears as a generation. The generation creates that. You can consider alpha trivials and right?
So instead, there are more classical categories. I will not explain this now, but we stopped partially of the square categories of cotangent and cotangent bundles. And it is equivalent to constructive sheaf category. So this is a special case. Where are stoppers at infinity? Stoppers for this. We stop made somehow. Oh, I will have this. Now my question is, where are the stoppers at infinity of cotangent bundles? Yes. So there are no rapid rates. So rev was the base. So if you put further definitions or further condition, M is complex manifold, then you can put the sheaf also, which is inside it, there is a more tractable, or there are more simplified with the local system categories. Category of local systems. On that. So this is a hierarchy of employees. And so from here to this place, the generalization from here to there, we obtain two generalizations. One is here you can speak about more general subjective manifolds than cotangent bundles. More general subjective manifolds. And the second feature is here you have no proper categories, so it is possibly infinite dimensional small space. So today we'll talk about Hodge version of part of this story. So maybe I can use another computer. So Hodge and Hasner. So here you have well-known Hodge and Hasner. Hodge Hodge version of this category. So it is called variations of Hodge structures. Alright. So an object in this category is a local system equipped with certain filtrations, which is a schematicization of what the structure appeared in progress geometry. And also you can generalize this kind of structure to more singular setup, which is known as theory of mixed ordinals. Or M cycle or equal cycle. And today's aim with microsheaves is about Hodge enhancement of this one. So the theory of Hodge microsheaves is not yet known, but we defined this kind of category for certain class of simplex manifolds, and today I will talk about some examples of this category.
Sorry, you say it's known?
Not known.
Not
in
known.
general.
In general.
Yeah. But we found some reasonable definition with some applications. So, as mentioned here, from this line to this line, you observe more general manifolds and infinite dimensional Hom spaces. So this theory should be kind of general version. Let me use micro local, the term micro local, and where we behave infinite dimensional version. Version or MHC. So such a theory we are looking for. Okay, this is the introduction. So M is defined as the Hodge microsheaves. And today, it's an example is defined for cotangent bundles and formings. I will discuss. Okay. No questions so far? So in this handout, let me explain the case of cotangent bundles. So cotangent bundle is already here, but as I mentioned, this theory should be in the infinite dimensional version. So in this section, somehow I will discuss well-behaved infinite dimensional version of MHM on the base space M. So let me set M to be a complex manifold. So yeah, for simplicity. So some parts of the story here can be explained for the manifolds, but we start. So part is that let me start with this part. and again, you have profile in Finland. So you have rough to category. Say the category of modules, which has already been there in REST OCaml, and this is known as equivalent to modules for chains of the base loop space of n. Here x is a point, and this is base loop space.
What did you mean by saying mods of favorite Fukai category?
Again?
Modules. I mean, you use this mod W.
This is a in choose. Yeah.
There's some extensions of correct Fukai. Right?
So you can recover.
Marita completion. You can always pass to mod something.
So let me say for this. Right, so here the cotangent fiber over point in this category, if you can push an object of this rough category, then the result, the more precise version of the result says that n of this cotangent fiber inside this category is hydromorphic to this ring, and you can check that this is a generator as already mentioned. Yeah.
And the morphism of which object?
Morphism as it's same as yeah. Yeah, this and then the project finance. So sorry.
Whole category does it?
Sorry?
The fiber.
Yes.
Does it generate the whole category?
Yes. So with this, we can do.
In particular, zero section.
There's section you can, for example, so you have this minus one, and you have this tangent in rough ones, maybe twice. Then you can surgery these 2 points. Then you will obtain this, and this is the so let me explain this with the observation in terms of sheaves. So in sheaves theory now, so this mode of W is the M is again by GPF equivalent to the category of derived local systems on M. So about it, derived local systems, and so you can ask that what is the corresponding object here. So this should be a generator. Such a generator was first found by Nadler. So let me write the derived category of sheaves with stratification. This kind of stratification. So only this point is a non-trivial structure. And you take the complement and we consider the constructive shapes smooth with respect to this stratification. Then you have an obvious inclusion from the local system. So local system is trivially stratified by this stratification. So let me write this inclusion by law. Then by general nonsense, you have the left joint of this factor. And you have skyscraper shape here. And then you have the image of this vector joint. And this is actually the picture one, this one. So in other words, it's just tautological figures, but in other words, so home block X is equal to kx this local system. This is just a rephrase of the definition of the left joint. But let me write here because we use this formula to define the next definition.
So this is some kind of regular representation.
Regular representation.
So if you think in terms of fundamental groups, there should be the regular representation, isn't it?
Yeah, it's kind of universal.
Yes, universal.
So we'd like to discuss somehow Hodge theory in this.
Sorry, did you answer this question? What is the another answer?
This is this.
Yeah, but what is it?
It's
Regular representation. So this omega it replaces fundamental group. This omega replaces fundamental group in case it's not k by 1. So that if it was k by 1, then it would be just representations of the fundamental group. And this thing would be the regular representation. If the group ring of the fundamental. Yes, infinite dimension. Yes.
You mean some infinite dimension?
Yes.
Let me next discuss Hodge theory. So this chain, this chain. This has an expression. So-called polar construction. Using the chain of that. So this is something like let me roughly. But you have to maybe use something even. Yeah. This some kind of this tensor and direct sound complex gives a model of the chain complex of the basic space. This is very long. And by using this explicit construction, which are line, gives a Hodge actually. Or the cohomology of the basic strings for his case algebraic varieties.
this universal local system, right? That's the answer, right? But you can this universal local system you can define by considering the universal.
So it's not actual rule system.
So even have a lot of the groups that still. Yes. So we need to consider some kind of Postnikov system in terms of that. Possibly say this.
I just mean to say that universal local system does not depend on the choice of a point, I believe.
So it does. Yes, it is. It's sort of like universal covering depends on the point. Yes.
Sorry.
So if there is a known point structure on this like homology to basic group space. Is this correct? Always like sister and that or if anything like let me see. For everything like this. Thank you very much. There is some refined version. So I'd like to give another body structure from our perspective. So for this, let me give a definition. So the definition of what you are. Maybe let me give a name for this. This is called the wrapping of students. This is called the wrapping of students. As we can change. So here, here we're going to change is Q. Or Q. Q is bigger. So a Hodge wrapping QX is an object of object E of input is let me use the 0M average X. This is by definition an object, the full subcategory of the end category when mentioned X, whose microsport is in the depth. Maybe let me say whose realization is processed. So and phrase given by some page formal coordinates. So let me say coordinates F I is so anyway, kind of local in version of these modules whose underlying shape is local. Such that if you apply this on P to this category, then it is the same as QX restricted to this category.
So note that this QX is not in this category. You can apply. So this equal. So this equality is
Sorry, this home is in which category?
sorry
In which category is this home?
in this category.
No, home from
This
QX. Yes.
This one is in the in the ambient home category.
And the first one.
First one you can consider equivalent. So this one or this. And then the cross category of this.
This needs to be a version of this adjoint functor
Yes.
condition.
Yeah. So this is the Hodge analog of this equal. So here you don't have kx inside the local system, but you can still apply all the kx and local system inside the shaper.
I'm just trying to understand. There's one category embedded in the other one. So
Yes.
which one is
So
the subcategory?
this is by definition for subcategory of this.
Yeah, I see. And what is it? The QX.
So just saying somehow f is mixed Hodge module over a local system, but with integer. Let me give a technical reason. Okay. Precisely speaking, so we have to, so in the definition, we should ignore, ignore a non-geometric morphisms in dimension or dimension or dimension. So, for example, in the category of the mixed Hodge structure, you have x1 trivial x1 for the rank 1 trivial Hodge structure, but it does not come from any morphism between underlying vector spaces. So we directly ignore this kind of non-Hodge state morphisms. So you have to actually take a non-full subcategory which consists of only kind of geometric morphisms. This is just technical remark.
The next one is 0. Is the next one from Q to Q0 in your category?
So after modification, yes. This is so anyway, so conjecture is appropriate. So so in this setup, the whole drop perhaps you just and so E is underlying G is low and QX and if you consider the home space, so in this modified category, let me write it as M.
Space. This gives you this high and close to
What is this with my eye?
This is H2. Yeah, this is facts. This is one general conjecture. We believe this conjecture does not hold true for the general. My first is
So your M is simply connected now?
yes. With side of is that this is conjecture rule for different.
Did you say what is in Hodge?
Its Hodge structure is this one. So you can, by using this kind of explicit over construction, you can explicitly give a Hodge structure on the base loop space, on the homological base loop space by using Hodge structure of M.
This integrals.
Kind of iterated integrals.
Iterated.
So this is kind of we believe that this conjecture gives more rigid construction. So the problem is sometimes
You write is over complex channels, right? M is a complex.
yeah.
So CPM.
Yes, shape here. So this one has description of where so through web twins Adam is quite expression description. So it consists of, so if you ignore any extension, if you ignore differentials, it's given by a complex consists of what, let's say, iterated extensions of this kind of constant sheaves. So it's cute. So so with some differential, and differential is given by was with some of the iterated con extension, iterated con iterated, or you can say twisted complex given by this kind of thing.
So it's not direct sum.
Not direct sum actually.
And I don't understand how to continue this sequence.
Yes. Sequence.
What's next after
0, 1.
Yeah, I will explain. So this extension is given by the hyperplane class. The hyperplane class has degree 2, so if you take the call, then you will obtain one street. And compared to there, you have fundamental class. Fundamental class has degree 2m. So if you take the column, then it has degree 2n minus 1. So maybe I missed it. It is not.
maybe white swell, so maybe this is sorry. Chris level to okay. So it seems there is some first minus. Sorry.
One should probably start with the rational homotopy type of Pn, which is a formal algebra, right? And just do the bar construction from that.
Yes, it's make a complete Heinz construction by using it, then you can again compare it.
Yes, okay.
That's okay. So by saying these extensions, you can see the weight. So weight is 2, and here is weight is 2n. So you can upgrade these iterated commons to the world of mixed Hodge modules. Then you can explicitly compare, as Misha mentioned. So you can also have a calculation of Heinz Hodge structure. In this case, by using the formality, then you can explicitly compare. And this is kind of.
I'm sorry, who is the next summon? Next summon.
Someone is maybe Q, 4, N plus something, or plus minus. So let me next go to the case of drinks. What you develop or drawings. Maybe we already talk about A and of tip opinion. So this is the case of one stock where gamma is Q, quiver is AN, and the dimension is 2. So in by this term, partial duality, very vaguely speaking, if you have augmented K-algebra, partial duality relation is something like this. Partial duality So as you can see from this, so to discuss partial duality, you cannot avoid to introduce grading. So to discuss this, we need grading. Okay. And yeah, we skip the explanation of the importance of partial duality, but it has a very much applications in the definitions already. And actually, in the study of presentation of the simple real algebras, maybe some improve Zoger studied partial duality for category of the algebra. And in their paper, somehow one way to study this kind of category, representation category, is by identifying it with sheaves or varieties. Then you have a Hodge enhancement. To make the Hodge more. Then from here to there, by introducing Hodge structure, you obtain a gradient, or in other words, you have an additional gradient structure given by Tate twist. So their philosophy says that this additional grading gives you to formulate Cauchy duality. So this grading, this is kind of just grading from mixed geometry. Gives Cauchy duality. On the side, so in symplectic geometry, there is also there are also Cauchy dualities found by different with symplectic SG. So likely observe the following Cauchy dualities. So inside theta P1 or theta S2. So you have the zero section. This is P1. So this is the issue one had in the previous lecture. And you have also cotangent point here. This is P1. And this is cotangent point. Also in the Framing case, we similarly have these things. So in Duan's talk, there is F5, 6, 3, 4 cores, cores. So their observation is, in some sense, this core and co-core are Cauchy dual pair.
The morphism algebras of those factors you know.
Yes. So, precisely speaking, that morphism of cross Fy is in a category is Cauchy dual so in the sky category, compact sky category. So this is 0. And actually, to discuss Cauchy duality in this setup, you have to give a grading. So it is already infinity algebra, but so you have a grading, but to discuss Cauchy duality, you need to have an additional grading. And their way to construct this Cauchy duality is first identifying this with Ginsburg algebra. Ginsburg algebra. And you can upgrade it into bi-grade Ginsburg algebra.
by heart. So then, by using additional way, you can discuss question during the end. That's way of the proof of a genetic break. So our question is about this. So question is mixed geometric explanation. And answer is yes. So to discuss, we have to look more the construction of microsheaf category for this kind of category. But anyway, you can see what I'm saying. So microsheaf category, to define microsheaf category for this category. And let me show the case of this one. So AA to come. You can obtain this microsheaf category by using say yeah, by considering the composition of this geometry into this one. You can consider it as this and this, and with shown from this. You know, two spheres, and we only consider on the right hand side, we only consider the hemisphere of this sphere, and this here only consider the left hand side of hemisphere, and here we consider the union of two hemispheres and the shells. So by using this cut-and-paste description, you can explicitly write down this type of category as a
What is my square?
so from the upstairs jobs, so this goes to this part. This part. So on the left hand side, what we have to consider is sheaf category on P1 with two singular points, two asteroids. Let me name them. M1, F1, 0. This is called forces for 0. And this is M2. Let me say this is P11 and this is P12. So P11 with possible singularities in M1 and 0. And the conflicts. Yeah. Let me go into that function. P1, 2, M2, 0. And you can consider the restriction to this geometry. It is SH C1 with 0. Singularity at 0. So
seem to be pushy ones.
Oh no, it's actually this. So let me consider this left hand side as she, and this hand side as this del she. This is cotangent. Then from here to there, you have restriction mark. And from here to there, you have restriction map and fluid. We composed with restriction. So since from here to there, so your shift here is restricted to there, which is on cotangent fiber. So to obtain this kind of shift description, you have to change the base and fiber. So that's the reason why we have weights. So with the Hodge module version, you can simply replace them with MHM. And you still have Fourier transform in this case developed by my co-author. So we can simply define in very the same way as the people program. So also in this case, again, so there is again Hodge graphing. I didn't define Hodge graphing for this microsheaves case, but you can define similarly for Fi exists. And if you compute again this kind of yeah. On the space graded like homology and this weight, then you will recover interval density, quite graded interval density. After linear change. So I mean, you can essentially recover this factor up to linear transformation.
These FIs, who they are?
Is this cotangent, and you can so
We can think
so corresponding project here is the skyscraper shape on this M1. But it's not so very you should
So you take these skyscrapers on different spheres, right?
right.
And what's the answer?
Which can call it. So yeah, let me explain in my example. This is so it's a case. Let me dropping with me dropping that one. So you have spheres, and if one starts from this side, and
again, this FI tilde is a kind of infinite dimensional microsheave. So let me write first some first parts of the description. So we first put the constant sheet supported on the complement of 0 on this sphere. Then if you restrict it to this intermediate geometry, then you will obtain that's QA1 minus 0. The Fourier transform this one is Q A1 push forward or QA1 minus 0. Here push forward is from it's just obvious on the equation from this one to A1. Then the object restricted to this one is being the same minus V1 0 push forward. And from here you have again some extension. So let me write some. So maybe I should now that sum goes to next level, and this gives you again sheet P1 prime 0 and restricted to sorry P1 0, restricted to N1 0. And again, Fourier transform gives you something. Again, you can construct it sometimes. And this kind of procedure you can proceed integrate many times, and you can construct certain twisted complex in the category of Hodge microsheaves, and taking coordinate, you will obtain wrapping of this F1. And with Hodge structure, you have to maybe I should shift here. With Hodge wrapping, you have to introduce certain twist. But here, somehow, because of the subtlety of Fourier transform in the world of Hodge modules, you have to introduce half Hodge state twist. So here you have this kind of twist. So you can introduce a half state twist by general categorical nonsense. And so actually, we have to grow up mixed Hodge module with half state twist. And you also have to take, as I mentioned, some kind of Hodge state version of such category. That kind of modification have already been appeared in DGS. It's okay to 1 minute.
How many you need? 2 minutes.
Oh, it's okay. 2 minutes. So looking from the animation, so how can I compare this with a Ginsburg BGA? So Ginsburg BGA in this case is given by this figure. Yes, so the relation are the same as one. So the H1 gives you this G2 G1, and the H2 is G1 G2. There are no other non-trivial differentials. And in this case, but we have bigrading. So degree of G is given by 1 minus 1, and degree of H is given by 1 minus 2.
Is n equals 2 in his?
Yeah.
And you describe which category?
This one. Yeah. So for here is about elements starting from this vertex. So you can put the corresponding elements here. So here it corresponds to E1, and here this one corresponds to G1. These are all cocycles. And here we can put H2G1, G1, H1. This is also cocycle. And here we obtain H1, G2, G1 minus G2, H2, G1, and so on. And if you compute the grading of these elements, and if you compute the degree and weight of these sheaves, then you can easily observe that it's related by simple linear change. So that's all.
Thank you. Questions, please? Yes.
Is your theory wrong? Your theory is for then the colloquiality also is for general. So,
For this case, in any case, with Avenger,
your expectation is
of course, more. So maybe it's not my conjecture, but it's overall conjecture. That duality or somehow partial duality for one partial resolution should be explained via this kind of language.
but they are not having any three plumbing of connected.
Yeah, but one thing you have to be careful is that our theory only works for homomorphic events. Since you have to discuss Hodge theory, you have to assume homomorphism.
This one presents quasi-isomorphic to pre-projective algebra of the A2 graph.
You mean
Does it have only zero?
so outside ADE,
Is there a reverse sheaves version of the story?
a Ship's version of the story is just forgetting grading.
Okay, but there is some, say, for toric case, there is some versions of graded versions, like Woods and Brad and Woods. Graded version of reverse sheaves on toric.
Yes, should be next. So high.
In this example, would be considered to be toric.
Yeah.
Sort of. 1 and 2 points on P1.
Yes, this is minimal resolution.
More questions?
No, let's thank the speaker again. And all participants for participating in this conference and speakers to give so great talks. Thank you very much for coming here, and please come in. Let's thank our people who helped organize this conference. This is Benji Nakamoto. This is Mokoshida, Saki Suzuki. Let's thank them.
The beauty of the artist. Let us see RxA.
Our meeting is over. We have a bottle of wine and drinking from the third floor.